lesson. Right, that's us good to go, folks. Welcome to week 3. We're looking at, still studying algorithms, but we're looking in particular one algorithm this week, and that algorithm is something called the serial search algorithm. You might hear it called the linear search or the sequential search, and we'll try and discover why in a couple of minutes. The first thing I want you to understand, this week there is 2 pieces of work due. We've got our live lessons today where I'm going to explain the concept of serial searching. You've got 2 tasks. One's GCSE past paper question. The second is a programming task that I expect you to complete on Python, or if you prefer, using Replit, the online editor. And they're due on Wednesday and Thursday. And Friday's lesson again will be pre-recorded. That is the format going forward. We meet Monday, you're doing GCSE questions, and we will review at the end of the week on Friday. So we shall begin. I'm going to share the screen and hopefully you will see your OneNote notes. Right, so the concept we're trying to grasp is an algorithm called a searching algorithm. It's extremely important in computing science that we are able to search data efficiently. The majority of information systems are built on databases where we require fast and efficient searches. And one of the searches we look at, first of all, probably the most basic, is a linear. So first of all, its name, linear. You might hear it called a serial. Think of a serial killer. They murder one person after the next, after the next. And the same with the serial search. We search one element after the next, after the next. You might hear it called sequential search. And again, in a sequence, we search each piece of data one after another. If you think about it in its most basic concept, it says searching through data one after another until you find it. There's a bookcase behind me. If I want to find my programming books, I'm going to have to look through. Hold on, we've a latecomer, have we? So if I want to find a textbook of my books, I have to start at the top of the shelves and go through each one individually. Another latecomer. I'm going through each of these books. Are you a Python program book? Are you a Python programming book? Are you a Python programming book? And I will search through in a sequence each individual book on all these shelves until I find the Python programming book that I'm after. That's the concept of a serial search. We search every single element and you compare it with the element that you want until you find it. Algorithmically, if we look at our flow chart, before we even look at the array, at its most basic, hopefully from last week you can understand these, we've got our start symbol. And we're going to look at the length of the array. That basically means how many items am I searching? If I have to search my bookshelf, I have to start at book 0 and count all the way over to whatever number that is over there. So let's say, for the sake of it, in this simple example, we'll go for an array of 7. Then it asks the first decision is, if it's at the end of the array, the search is over. So is it the pointer at the end of the array? Yes, end of search. And we haven't found it. If it's no, we compare, is the search item found? And if it's yes, we can output it. If it's no, we increment the pointer and we do the comparison again. So algorithmically, if you think about it again, I'm going to search this shelf. I start counting at 0. Are you the book I'm looking for? No. Are you the book I'm looking for? No. Are you? No. And I go through. Each time I'm incrementing my counter. Do you equal it? No. Unless I find it, found. If I get to the end of the shelf and I haven't found the book, I return book not found or not found. And that is the concept of a serial search. There is different ways to implement this, and I'm going to look at 2 of them today because that's what your task this week will be. There'll be some theory questions and an implementation. Before we get to the implementation, I'm going to highlight in your notes as a cheat sheet, and this tells you everything you need to know about the serial search. Now, again, Apologies for the mistake. There is a mistake, but it's correct. This search item should be 2. But let's look at it. First of all, in your theory questions for this week, you will be asked, what is it? And here you've got a definition. A sequential search, it's this idea that we search through elements one at a time, making a comparison. There is a pseudocode implementation, which I'll look at in Python in a minute, and there's an explanation. We start counting at 0, the first element in a list. At the start of the search, we said we haven't found it. Found equals false. We iterate through, or we look at each element in the search criteria and we make a comparison. If the element is the same as the search criteria, we found it and we can flip the found to true and we can stop searching. If we get to the end of it and we haven't found it, well, found is still false and we can say we haven't found it. There's a work through in your cheat sheet. And in this example, if you look at it, here is our list. 4, 5, 7, etc. And I'm looking for the number 2. I start at element 0, which contains 4, and I make a comparison. No, you're not 2. It's false. In the next iteration, I look at the second element. 5 doesn't evaluate through, so it's false. In the third iteration, I look at index 2, not 1, 2, and at 7. 7 doesn't match my search criteria, false. And so on until in my fifth iteration, I'm looking at, my sixth iteration, I'm looking at index 5. Well, you're a number 2. They match and we can return found. Again, we'll look at this just in a second programmatically, but your theory questions, you must know the advantages. And the primary advantage is simplicity. It's extremely easy to understand and to implement, which you will do by the end of the week. And another key advantage is, think of the bookshelf. They can be in any particular order. You do not need an ordered array because we're checking every advantage or every element. The disadvantages, it's extremely inefficient. I have to search through every single book. The worst case scenario, the book I'm looking for, the element I'm looking for is the last one in the list, and we have to search through them all because the list isn't ordered. If the list was ordered, we would know when we found it, and it's not going to be past this point, we could quit searching. So main disadvantage is, we say, extremely inefficient because you may have to search through all the elements to find the one that you're after. So I'm now going to flick to some Python programming lists, but bear with me because there's people still seem to be looking in. So Python implementations of the serial search. Where are we? Hopefully you can see this on screen. If you can't, I'll upload the recording of the video and you can hit pause at this stage. I've got 2 linear search algorithms on the board. The first one is based upon this, what we call the traditional implementation. And it starts off, let me see if I can just enlarge this view. Bear with me, see if I can present this. Zoom, 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 zoom. And I'm hoping this is a wee bit clearer on the screen. So my first search criteria, or linear search, again, we're passing in 2 parameters, the actual array or the data that we're going to search. In this case, the bookshelf will be passed in, and the criteria, what is it that I'm looking for? We start the algorithm with saying, we haven't found you, found equals false, and the index is where we're beginning the search. And index 0 is obviously the start. We go into a while loop, and while index is less than the length of the array and we haven't found you, or found equals false, we make a comparison. So this is the comparison. So I'm comparing each of the elements, and if it evaluates that the index, whatever's in that index position, is the same as their criteria, we found it, and I can print a simple message. I find you at position 1, whatever it is. If it's not, we must increase the index and go back to our iteration. And that will continue and continue until we get to the length of the array. If we still haven't found you at the end of the array, find will still be false. So if I'm going to run this, and if I run the linear search, sorry, I better program it, let's call it. So I'm going to call, this is, I've got an array called games with a number of games, and I'm going to search this. With me, what was that called? Capital L, that was linear search A, and I'm going to pass in the games array, and the criteria I'm going to look for is GTA. So I'm calling this function, I'm passing in the array and the criteria, games, and I'm looking for this element. And when I run, you can see GTA was found at position 2. Why? Because we've iterated through the array at index 0. Are you GTA? No. Incremented. Are you GTA? No. Are you GTA? Yes. Found equals through. We break out of the loop and we print it was found at position 1. So that's one way I've implemented. The second way is probably more simple, and it just uses a for loop in Python, but it's the same idea. I'm iterating through it, and in each iteration, if the element in the array matches, I'm returning the position, or in this case, I'm returning I. So I'm going to call this, in fact, I'm going to have to print this because this is a function. So I'm going to print linear search B, and I'm going to pass in the games array. And this time I'm going to search for Super, spell it correctly, Super Mario Bro. So when I run this, it just returns 4. It was found at position 4. 0, 1, 2, 3, 4. Let's look at this. So go back to this and let's see what happens if I go and look for GTA 2. And we run it, nothing. All right, it didn't find it. So we could update this algorithm that else that if it's not found, if found equals false, we could say item isn't found. So at the end of the loop, we could say if not found, print your nest string criteria. We go back and run it. GTA 2 was not found because it's not in the array. So you've got 2 implementations, and that takes us to the end, well, not the end of the lesson, just the review of the lesson, and we're going to look at the homework that's been set for you. So in your assignments, there's 2 tasks that should have come online. In fact, I should have posted up here by now. Homework 1 and 2. Homework 1 is straightforward. It's a Word document. It's past paper questions. I want you to answer these questions on screen. The cheat sheet will help. So straightforward GCSE questions. The second assignment is homework 2, and this is your programming task. And it asks you to create a program that uses a linear search function. I've provided a hyperlink. There's pseudocode in your cheat sheet and your notes. You can watch this video again and look at the way I've implemented the search algorithms. But this is due Thursday, I think, Thursday afternoon, you need to write this program. So, questions, folks. Feel free to turn on your mic and ask any questions. No. Right, just before we sign off, we're going to review linear search. We search in a line, 1 element at a time. What are we searching? An array. We're comparing a criteria against each element in the array. If we find it, we return true. If not, false. You can pause this video and you can look at implementation A or implementation B? Sorry, I'll just put them on screen for a second. So I'll give you a chance, if you're watching this in review, you can pause it and you can look at both of these criteria. If I get a show of hands, folks, we're going to end the lesson. Is everyone clear that they have 2 tasks and the review will be on Friday? Hit the raise hand. So, folks, if you want to hit your raise hand icon. Is there a problem, folks? Are you not getting sound? Anyone hearing me, folks?
Yeah.
So we're back in the land of the living. Has anyone any questions about the linear search? So again, a show of hands, raise your hand and we can sign off on the lesson that you know what to do.
Sir, we've raised your hand.
Good, I'm missing a few here. Right, any questions, post to the team, message me or other people in the class, and I'll post the answers on Friday. Everyone happy enough?
Yeah.
Good. Laura, everything okay?
Yep.
Good. Who else am I randomly picking on here? Nathan, what's the crack?
Nothing, sir.
Nothing. You understand the linear search, Nathan?
Yeah.
Where are you going to find the linear search algorithm in Python?
In the video somewhere.
Good. Kevin, where are you going to program this, in idle or Replit?
Idle.
Idle. Yashin, where are you programming?
Probably I'm Replit.
Replit. And Brendan, if you haven't a clue, who's going to help you program this?
You, sir.
No, I'm not. Guess again, who can help you program this?
Friends.
Friends, anyone in the team. And if the team can't, I will help you. Folks, it's a pretty straightforward task. Try your best. That's all I can ask of you. And again, post to the team or post to me. So look, we will chat again next Monday. Have a good week. Stay safe and we'll chat later. Bye, folks.
Bye. You too, sir.
All right, bye.
Bye, bye, bye.
Hey.